Today we are going to talk about the Lat 11, which is simple machine, and we will focus on the Pulley, which is one of the simple machines. We will see how using a simple machines we can do the job easier. However, when we are talking about the work, the story is different. Then we will see what happened with the work when we use a simple machines. There are 6 different kinds of simple machines. We have the lever, pulley, wheel and axle, inclined plane, wedge, and screw. All these machines made the job we had to complete easier in 2 different ways. One is they can change the direction of the force we need to apply, or change the magnitude of the force. Here we had some examples, and we can see in these examples is we use the simple machines every day. Here we can see how we can use the inclined plane. For example, the axe is one example of the wedge. The hammer is one example for the lever. The knob is one example for the wheel and axle. The mechanism to close the bottle is one example of the screw. And the flat hoisting is one example for pulley. But today we are going to concentrate, we are going to focus in this simple machine, the pulley. A pulley can be fixed or movable, and the pulley is a wheel or a group of wheels with a rope, or can be also a chain in a group ring that is used to lift something up. There are different variables that we need to take into account when we are trying to study the pulley system. Then two of these variables are the resistance, which is the force, is the weight, is the weight of the object we want to lift. This is the resistance. And this is why the resistance is mass times gravity. It's basically the weight. But the earth force is the force we need to apply to lift that object when we use the simple machine. The other variable we need to take into account is the mechanical advantage. This indicates how many times the force required to lift, yes, means the earth force, can reduce the load, means the resistance. Then this is why we can calculate the mechanical advantage if we divide the resistance by the earth force. This is the ratio the resistance to the earth force. But we can also know the mechanical advantage if we know the number of strings which directly support the resistance. And when we calculate the mechanical advantage using this concept, we say this is the theoretical mechanical advantage. Yes. What is in theory? Yes, in theory. Then if the number of strings that directly support the resistance is 1, then the mechanical advantage is 1. And probably you say, if the mechanical advantage is 1, why we are using that simple machine? And remember the other thing, why also we use the simple machine is because this can change the direction, yes, can change the direction of the force. And you need to lift this object up, but instead of lift the object, just you pull. If you use, in this case, this simple machine, you have to pull down. And sometimes it's better, yes, it's better to pull than lift something up. Then remember, the simple machines can reduce the effort we need to apply, but also can change the direction of the force. And let's talk a little more about the mechanical advantage. And remember, the mechanical advantage we can calculate experimentally if we know the resistance, we know the magnitude of the resistance, means the weight of the object, and the effort we need to apply. Yes, is the force with the force we pull the rope. And also we know the theoretical mechanical advantage if we know the number of strings that directly support the resistance. And let's try to analyze what happens if we want to lift up this box and we don't have any simple machine. Yes, then we need to lift this box up. And let's think now, what is the force we need to apply? Remember, when we lift some object, what happens is we are working against the gravity. And this is why the force we need to apply will be mass times G. If the mass is 10 kilograms, G is 9.8 meters per second squared, then the force will be 98 Newton. Maybe we can write this one here. The force in this case will be, mass will be 10 kilograms. Probably will be good to put two significant digits, and here will be 9.8 meters per second squared. Then the force will be 98 newtons. And this is why we had here 98 newtons. Then this is the force we need to apply if we want to lift this object, 98 newtons. Then let's see what happens if we want to do the same thing, but now we want to use this simple machine. We want to use this movable pulley. And what happened is, here we had the box. We want to do the same thing. Then we know the resistance is 98 newton. Yes, is the weight. But in this case, we had two ropes. Yes, we had two strings. Then the mechanical, this is the how many strings directly support the resistance is 1, 2. Yes, and this is why the theoretical mechanical advantage in this case equals to 2. That it means, because this object, this box, is supported by these two strings, then the force we need to apply in this will be reduced by 2. Why? Because the mechanical advantage equals to 2. And instead of applying 98 newtons, we need to apply 49 newtons. Why? Because the force is reduced by 2. And you can see, if you divide 98 divided by 49, you will get equals to 2, which is the mechanical advantage. Then the mechanical advantage is telling you how many times the force you need to apply will be reduced. Yes, in this case will be reduced by 2. But this is in theory. Yes, in theory. If we don't take into account, for example, the friction between the string or the rope and the wheel, then this is ideal. Now we are going to talk a little more about the type of pulleys. One type of pulleys is the fixed pulley. This pulley is attached to something and it doesn't move, like we can see in this configuration. Because there is one string that directly supports the resistance, then the mechanical advantage of this type of pulley is equal to 1. And this is why this kind of pulley doesn't reduce the effort you have to apply, but this system change the direction of the force you need to apply. Yes. Then instead of move this one up, you pull this one down. Yes. Then change the direction of the force. And one of the examples is the flat hoisting. The other kind of pulley is the movable pulley. In this case, one of the end of the rope is fixed and the wheel is free to move. In this particular example, the mechanical advantage equals to 2 because there are 2 strings that directly support the resistance, and we have the mechanical advantage equal to. Means the effort we need to apply is reduced by 2. However, we can see in this particular example, there is no change in the direction of the force. And one of the examples is the cranes. Yes, is the big machines using for the construction. Yes, here is they apply this kind of pulleys. The other type of pulley is the compound pulley. Is consistent of fixed and movable pulleys. And in this particular example, we had 3 ropes that directly support the resistance, and this is why in this particular case the mechanical advantage equals to 3. Then again in this example, the effort is reduced by 3. Yes, instead of, for example, if the resistance is 30 newtons, then the force you need to apply if you use this simple machine will be 10 newtons. As will be reduced by 3. But also in this particular example, the direction of the force doesn't change. Yes. Then these are 3 different types of pulleys. And again, here there is one example. Is one of the this is a crane. This is that system is using in these machines. And here we can see many streams in this pulley system. Now we want to talk about the pulley and work. Now we know the simple machines made the job easier. Now let's see what happened with the work. When we say work, is the way we define work in physics. Remember, work is force multiplied by the distance. And what happened in this example, we had a movable type of machine. The mechanical advantage equals to 2 because we had 2 strings that directly support the resistance. And let's think we want to move the resistance 10 centimeters. Yes, we want to move this resistance 10 centimeters. Like this happened like in life, nothing is free. Yes, what happened is the pulley system reduced the effort you had to apply. But what happened with the distance? If you want to move this object some distance, less than 10 centimeters. And to move this object 10 centimeters, you had to pull the string 20 centimeters. Then in the same way, let me write here the mechanical advantage of this equals to 2. Yes. Then the effort you had to apply is reduced by 2, but what happened is then the distance is increased by 2. Yes. Again, the effort you had to apply if you had this type of pulley, if the mechanical advantage equals 2, the effort you had to apply will be half, But what happens if you want to pull this one, if you want to move up this object 10 centimeters, you had to pull the double of the distance. You had to pull 20 centimeters, which is 0.2 meters. Yes. And this is, I say, in life, nothing is free. Yes. And the simple machines reduce the effort, but the distance you had to pull the rope will be the double in this case if the mechanical advantage equals to 2. Then this is why if we calculate the work done by each force, then I want you to concentrate in these values. It's just because here we have many numbers here, but I want you to focus on these values. And let's calculate the work done for each of these forces, for the resistance and for the earth force. Let's calculate the work done by the resistance. Then remember, work is force multiplied by the distance. In this case, the force is the resistance. This is why we had here work equal to the resistance multiplied by the distance of the resistance force. Then the resistance is 1.996 newtons multiplied by the distance. By the distance is 0.1 meter. Why meter? Because we need the same system of units. Then if we multiply this, we will get 0.196. And if we want to really be careful, we want to be careful with the significant digits. The correct answer here will be 0.2 joules. Let's now calculate the work done by the earth force. And remember, work is force multiplied by the distance, but in this case, the force is the earth force, and the distance of the earth force. Then earth force is 0.98 newtons, distance 0.2 meters. We want the same system of units. If we multiply this together, we will get 0.196 joules. And again, if we want to be careful with the significant digits, then this will be 0.2 joules. And we can see, if we compare these two results, we can see the work is the same. Then this is why the simple machines reduces the force you had to apply. Remember, also can change the direction. Yes, can change the direction of the force, but it doesn't reduce the amount of work you must do. Then reduce the effort, but the work you had to do at the end is the same. Then with the simple machines, we are able to reduce the force that must be used by exerting that force through a larger distance. Then the earth force we need to apply is reduced, but we need to apply this force through larger distance. This is why at the end, the work we had to do with or without simple machines is the same. Yes, just what the simple machine is doing is reduce the effort you had to apply, but the work you had to do is the same with or without simple machines. Let's try to analyze a little more examples in which we can see the work done with the effort and the resistance, they are the same. And let's see what happened with this pulley system. This is fixed pulley, and we know in this kind of pulley, the mechanical advantage equals to 1. Yes, we had one string here. Then what happened now with the work done by the resistance? Then if we calculate the work done by the resistance, we need to multiply the resistance, this is the weight of the object we want to lift, multiplied by the distance we want to move the object. And we want to move the object 10 centimeters, but remember 10 centimeters equal to 0.1 meter. Let me write here, equals to 0.1 meter. Then this is why if we multiply these two numbers together, we will get 10 joules. And let's now calculate the work done by the effort. Then the work done by the effort equals to effort will be 100 newtons multiplied by the distance, which is 0.1 meter. Then at the end, we had 10 joules. Then we can see the work. If we use this simple machine, the work we had to the work we need to do is the same, but in this particular case, the effort is not reduced because we know in fixed Pulley system, just change the direction of the force. And let's see what happened with the next example. In this case, we had two ropes that directly support the resistance, then the mechanical advantage we know is 2. If the mechanical advantage is 2, then we know this resistance is reduced by 2. This is why here we have 50 newtons. And what happens if the mechanical advantage equals to the distance we need to move, as we want to move the resistance 10 centimeters, but we need to pull the rope 20 centimeters to move this 10 centimeters. And if we calculate the work done by each of these forces, by the resistance and the effort, then this nothing changed because we had exactly the same situation in both. Yes, we had 10 joules. Let's see what happened with the work done by the effort. Then the effort will be 50 newtons multiplied by the distance will be 0.2. Then finally we had 10 joules. Then again, the work we had to complete is the same. Yes, the same. If we use any simple machines, the work we had to do is the same as if we don't have any simple machine. But what is reduced in this case? The effort is reduced. As in this case, the effort is reduced by 2 because the mechanical advantage is 2. One more thing you can see here, the direction of the force also it changes. Yes, in this particular configuration, the direction of the force changes also. Let's see what happened in this case. Now we know what is the mechanical advantage of this simple machine is 3 in theory. Yes, in theory equals to 3 because we had 1, 2, 3 ropes. Then what we expected is this, the effort we need to apply, yes, the force we need to apply to the rope will be reduced by 3. This is why here we have 33 and 1/3. But what happened if we want to move this resistance 10 centimeters, we need to pull the rope 30 centimeters. Yes, we need to pull 3 times more the rope. Yes, and if we want to move up 10 centimeters, we need to move this one 30 centimeters. Then the work done by the resistance will be 10 joules because we had the same situation. Even if we had different Pulley system, we had the same situation here. Then this is why the work done by the resistance is the same. Let's see what happened with the work done by the effort. Then the effort is 33 and 1/3 multiplied by 0.3. This is the distance of the effort will be 0.3. If we multiply these numbers together, we will get again 10 joules. Again, the work done by the resistance and the effort are the same. What the simple machine is doing is reduce the effort you need to apply. Yes, it's reduced by 3. And in this case, again, the direction of the force was changes. Yes, and this is in this direction. This is the last example. Here we had a compound Pulley. we had fixed and movable pulleys, and in this case we need to count how many strings support directly the resistance. We had 1, 2, 3, 4. Then the mechanical advantage equals to 4. Then what happened? This is the theoretical mechanical advantage. Yes. Then in this case, we had the same problem. We want to move 10 centimeters this resistance, which the weight is 100 newtons. Then because the mechanical advantage is 4, then this effort will be, the force we need to apply will be reduced by 4. And this 100 divided by 4 will be 25. But the distance we need to pull the rope, if we want to move this object 10 centimeters, will be 4 times larger, will be 40 centimeters. And because we had here the same situation, then we know the work done by the resistance is 10 joules. Let's see what happened with the work done by the effort. Then will be, the effort is 25 newtons multiplied by the distance will be 0.4 meters, because we want everything, all the units in the same system. Then finally we had 10 joules. And again, the work done by the resistance and the effort they are the same. However, what happened is, using this Pulley system, the effort is reduced by 4. Yes? Instead of you apply 100 newtons, just you need to apply 25 newtons. And this is why simple machines reduce the force you have to apply, but doesn't reduce the amount of work you must do. Also, with the simple machines, we are able to reduce the force that must be used, but exerting that force in a larger distance. And this is why at the end the work is the same. And here the work is the same because we are trying to do exactly the same. Yes, if we want to move this resistance, which the weight is 100 newton, 10 centimeters. Yes, the work we want to do is exactly the same. This is why we have 10 joules, 10 joules, 10 joules in all the cases. Then now let's talk about the relation between the resistance, effort, distance of the resistance, the distance of the effort, and the mechanical advantage. Then we know the mechanical advantage in theory equals to 1. Yes, equals to 1. This is why we had 100, 100. But this is in theory. In the real system, what happened? There is a friction, for example, between the rope and the pulley system. Then, because of this friction, then the mechanical advantage can be 0.80. Yes, can be 0.75, 0.90, because there are some force like friction that act in opposite direction of the motion. Yes, this is why we say in theory must be 1, but in practice can be less. Yes, can be less. Then let's review how we calculate the mechanical advantage, the experimental mechanical advantage. And this is how we calculate, this is how we say the theoretical mechanical advantage by the number of the ropes, yes, or the number of strings that directly support the resistance is 1, 1. Now in theory, experimentally, we divide the resistance divided by the effort, and we should get the same. And you can see there is no units because the units cancel out. Yes, yes. This is why the mechanical advantage doesn't have any units. And you can see the relation between the force in this case and the distance is inverse. Less in general, there's less force, more distance. Here, because there is the same in the fixed pulley, we had the same the resistance and the effort are the same value, and this is why there is no change also in the distance of the resistance and the distance of the effort. And the other way we can calculate the experimental mechanical advantage is if we divide the distance of the effort divided by the distance of the resistance, and we will get also 1. Yes. Again, this is the maximum mechanical advantage. Yes. This can be less because of the friction. And here you can see again, there is no units for mechanical advantage because they cancel out. And let's see what happened in the second system. We had 1, 2 pulleys, mechanical advantage 2. Then what happened if we divide the resistance divided by the effort, we will have 100 divided by 50 equals to 2. But we can also calculate the mechanical advantage if we divide the distances of this force in which we apply these forces. Then will be 20 centimeters divided by 10 centimeters will be 2. And here no problem with the units because we are just dividing the same units. Yes, if you divide 0.2 divided by 0.1, you will get the same. You will get 2. And now you can see if the effort, if the force is reduced, the distance increases. Then if the effort is reducing, what happens with the distance? The distance is increasing. This is why force and distance, they are inversely related in this case, as in the simple machines. The distance and the effort are inversely related. If the force is reducing, the distance is increasing. And this is why, because the relation is inverse, this is why here we need to, on top we had the distance of the effort, yes, and here we had the distance of the resistance, yes, we had the opposite. We had here in case when we are calculate the mechanical advantage instead of the forces. And let's see for the third. Now we know the mechanical advantage is 1, 2, 3. Then the mechanical advantage if we calculate using the forces, we had 100 divided by 3.13 and then equals to 3. And this is we expected 1, 2, 3. Then the same happened with the distance. Then 30 centimeters divided by 10 centimeters. Let's cancel out here, the units cancel out, and then equal to 3. And the same happened with the last example. We had mechanical advantage 1, 2, 3, 4. This is, we count the number of streams that directly support the stream, and then directly support the object, then the mechanical advantage equals to 4. Now to calculate the experimental mechanical advantage, we divide, one way is divide the resistance by the effort, and then in this case we expected 4, but the other way is we divide the distance of the effort divided by the distance of the resistance, which is, you will get also 4. Then this is how we can correlate all these variables, as all these variables. And remember, what is reduced in the Pulley, when we use a Pulley system, then the Pulley system reduces the effort you need to apply, but however, the work you had to complete is the same. Yes, it's the same. It doesn't change the work. Then finally, what we are going to do in this experiment, then you will conduct the simulations, and the simulation in which you will have different type of Pulley systems, and then you will calculate the experimental mechanical advantage of the systems in terms of the resistance and the effort. and you will demonstrate the number of extremes that directly support the resistance in a Pulley system is equal to the theoretical mechanical advantage of the system. And also you will see a simple machine in general, yes, but we will see in the Pulley system in a Pulley system or in a simple machines, reduce the force you had to apply, but it doesn't reduce the amount of work you must do. And this is you are going to try to do when you conduct the simulation about the Pulley system. And this is all I had to discuss for today.